everybody, and welcome back to Coding Challenge number 2 with the Wayne State C2 Pipeline Innovation and Curiosity Center. I'm Michaela, if you don't already know me, and I'll be walking you through the coding challenge for today. So we're going to be working with C++ again this week because I thought it would be a good thing to continue on that learning path as we got our feet wet a little bit last week with C++ and how that coding language works. So without any further ado, here's Coding Challenge number 2. Okay everybody, so Coding Challenge number 2 is asking us to code a rock, paper, scissors game where players play against the computer. The program should include logic operators, if statements, and the use of the rand function. The results should print the winner of the match. So at this point, if you know a little bit about these things, I completely encourage you to go off and try and code it on your own and check back with us later. But if you don't, we're going to start coding right now. So let's get started. Okay, so we're going to use the same compiler as last week. So we're going to use this online GDB compiler. It's free and I get to it just by Googling it. If you need a little bit extra help on how to get to this compiler, you can watch the video from last week and we go in depth on how to get here. But usually if you just Google online GDB for C++, it'll be the first thing that pops up. So the first thing that we want to do, of course, is modify our header. So we learned last week that this is our header, and it usually tells the programmer what the program's doing, who wrote it, when it was written, and some different stuff like files and that kind of stuff. So the first thing we want to do is modify this, right? So to write a comment, which is what the header is composed of, you write 2 backslashes, and you can write your name, and maybe the program title, and then maybe the date it was written, just so that you have it later for your records. So now that our header is finished, we can go ahead and look at our main. So we learned last week that this cout stands for characters out, and it's going to print hello world when we finally run our program. Well, we don't want to print hello world this time because of course we want to write a rock, paper, scissors code. So we're going to go ahead and get rid of this hello world. And now our main is ready for whatever we need to write. So now up here we have to include some different kind of libraries. So libraries put different kind of functions and things that we'll need for our program into our CPP file in our project, right? So I'm just going to copy and paste because it's a lot. So all of them except this one, so ignore this con.io. But all of these except for this one is one you're going to need. So IOStream is a standard one, that one was already there. This one is including the C standard library, which is the language which C++ is derived from. You need this stream because this takes in, your characters out. So we're going to need that one. String, of course, includes the string data type, which we learned a lot about last week with our Mad Libs program. CMath includes the random function that we're going to need, and then we're going to need time too because that's what's going to determine our random function a little later on. So we're going to pause here and just give you some time to make sure you have all these included, and then of course using the standard namespace, that just stays where it is. So we're going to pause here while you guys write all of these into your program. Okay, so now that our compiler is set up, it should look like this. Don't worry about this, I just commented out here so that we can follow along easier with the video if you're looking at the CPP file when you're done with this. So the first thing all good programmers do would be to welcome their user to the program. So we're going to use cout here, and this is character out again, followed by the token here, and then the double quotations with our message inside. Welcome to rock, paper, scissors, of course, followed by another token and an end line. And then you can put underneath, you can do another end line if you want to. That just adds a space in between the first part and the next part that we're going to do. So the next thing that we have to do, if we think about this, like if we're playing rock, paper, scissors, or you're writing this program, would be to figure out how to ask the user what they want to input. So this would be the equivalent of choosing rock, paper, scissors in your mind. So we have to have a variable to store that into. So let's create a variable to store user input into. So again, we're going to use string, which we included in this class up here. So we're going to use the keyword string followed by this key term, or followed by whatever you want to put in there. It's just the name of the variable, and followed by a semicolon, of course. So now that we have that string variable, we can read into the string variable. So we can call we can see out first, because we need to tell the user that they need to enter something, and we'll just say, please enter rock, paper, or scissors. So now, if you remember from last week, the next step would be to read into this variable. So we're going to have cin, which would mean characters in, and we're going to read it in the opposite way that we would see out, and then we're going to use this user in variable. Now cin will read all the way up to the first white space character, which would be like a space or a tab or an enter, and so that takes care of that. So now that we have what the user wants as their input, we have to then put that into numbers, because our random function that we're going to use to generate the computer's output a little bit later is going to work with numerical data types. So we have to declare an int. So declare integer variable that represents user's input. So we can call this whatever we want to, and remember that this data type is called an integer. It's just the whole number. So use the keyword int followed by whatever you want to name it. I'm going to call it user in num just to keep it uniform here, of course. And then what we have to do now is we have to assign the different numerical data types to rock, paper, or scissors. So to do this, we have to use like an if statement. An if statement is like a comparative statement that accounts for all different cases in which your program could run into. So in this case, like we have if the person enters something that's correct, so if they enter rock, paper, or scissors, then we want them to go to the next part of the program. But if they enter something that's not recognized, like we don't want that to throw off the whole entire program, so we're going to have them loop back to the beginning or do whatever. And you can have it continue within the program, and that's what we're going to do today, but there's a whole bunch of different like if or else cases that you would like to account for in major programs. Kind of like if you were on a web page and there's a red X in the top corner, so a programmer would be like, if that user hits the red X, then the program will close down, but if not, then it stays open. So they're really important in everyday programming languages. So the syntax for this is if, and then it's followed by our statements, right? So if the user enters paper or rock just the way it is, so if user in equals, and we use a double equal sign to compare things, and we're going to use quotations, and we're going to follow it by rock. So if the user enters rock, then we know that it's an okay statement. Or another case where the program would be correct is if the user entered paper. So in order to use that kind of syntax or that kind of language in programming, we use the double vertical bars here, and that means or. So that's going to be our logical operator that we're using in this program. So that means if user in also equals or double equal signs paper, it's also accepted. So our last case, it could also equal scissors. So we're going to have or again. User in equals scissors, and that accounts for every case in which it's correct. Now, if you want to include like capital, all capital letters, all lowercase letters, all that kind of stuff, then you would just continue on with the statements and continue programming. So you could have this as an acceptable case too. It just depends on how detailed you want to get with your program, right? So now that we have our first case done, we're going to follow it by curly braces because your if statement has to be included in curly braces, and we're actually going to have a nested if statement here. So in order to set the input equal to a number that we're going to use later on, we have to have separate cases for each one of these. So if the user in equals again, so our first case would be rock, then we're going to have the curly braces, and inside the curly braces we're going to set our user in num, so our integer variable, equal a single equal sign here because we're setting something equal to this data type, to this variable, and we're going to set this one equal to 1. So then that takes care of rock. So then our next case would be else if. So this is the next case in a if statement. So you don't follow an if by another if, you follow it by else if. So we have user in equals again because we're comparing, and then we have paper followed by curly braces, and inside those curly braces we have user in num again. We're setting that equal to the integer value 2, so only one equal sign. And then our final case is going to be our else statement. So that's our general case. If it's not rock or it's not paper, then we know that up here it has to be scissors. So we don't have to write anything up here. We can just have our curly braces and our user in num, and we can set that equal to 3. So now our inner if statement is done because we concluded with an else statement. We have to figure out our outer else statement. So if it doesn't equal any of these values, then we know that we want it to send an error to the user because they entered something that was not recognized by the program. So we have to have our else statement here, and we're just going to see out a simple message to the user. So what you entered is incorrect. Please try again. So then the user knows why the program is getting an error. So now we should have a total if-else statement block here that assigns what we inputted as the user and turns it into a number to later compare in the random statement generated by the computer. So at this point, when you run their program, which reminder that it's going to run down here, we should get welcome to rock, paper, scissors, so our welcome message, and then please enter rock, paper, scissors, and it should just sit there right now. So at this point, our code is completely correct. So we're going to pause for a minute while you guys finish up this and then come back for part 2. Okay, so now that we have the first part all done, it should look something like this. We're going to move on to part 2. Again, just commented right here so that it's easier to follow along a little bit later. Okay, so the first thing that we have to do with part 2 is we have to set up the random variable that's going to be the computer's answer. So again, remember in the first part, it was 1 was rock, 2 was paper, and 3 was scissors. So what we have to do is we have to use this function to create a number and a seed and all that kind of stuff for the random function to go off of. So we're going to just comment this seed for random function, of course, and then we have to use this exact line. So srand is a function, and then it's going to be going off the current time pulled from your computer filled with the parameter null. And so what this does is it just gives it something for the compiler to go off of, so it knows that when this is run, it sets everything to 0. So now that we have that input, we have to actually create the random function. So we need a random function that will return 1, 2, or 3. So because we only wanted to do 1, 2, or 3, we have to mod the random value that srand is going to give us, and then we have to add 1 to that. So because it's going to be at 0, 1, or 2, so to get 1, 2, or 3, we add 1 at the end. So we need to use this line of code. So first we have to declare a variable. So we're going to call this the CPU in just to match what we were using above. So we had the user in, now we're using CPU in, and of course this is going to be an integer, right? So we have the CPU in here, and we're going to initialize it right in the same line. So we're not going to have a declaration line and then a initialization line. We're going to do it all in one. So we have this integer CPU in, and we're going to set it equal to random. Now random is a function, so it needs these parentheses after it, and it's not going to be filled with anything because it's going to pull from this seed right here. So we need random followed by moduloso, which is the percent sign, and we need to mod it by 3. So when you mod something, it's actually giving you the remainder of whatever you do. So if I have 9 mod 3, the answer would be 0. Likewise, if I had 10 mod 3, the answer would be 1, right? Because 3 goes into 10 3 times with the remainder of 1, so the result will be that 1. So now, because it's going to answer in 0, 1, or 2, we still need that third option, so it needs to be 1, 2, or 3, so we're going to add 1 to that. So anytime this program is run, it's going to generate a random number, and then it's going to divide it by 3 and return the remainder of it, and then add 1 to that number, and then store it in the CPU in variable. So now that we have that done, we have to take that number and then put it into text form. So we have above, we know that 1 is rock, and 2 is paper, and 3 is scissors, so we need to do that same thing here. So we're going to use an if statement again. So we know that if the CPU in variable is equal to 1, so remember we're comparing it, not setting it equal. So if CPU, after it's run through this random function, is equal to 1, then we're going to curly brace first, and then we're going to set the string variable, which we have yet to declare. So we need to go up here and set string variable. So we need the keyword string, and then we need to set the variable. It doesn't matter what you name it, but to keep it in line with everything else, CPU in, and then I'm just going to call it string after. So then we have CPU in string equals, remember 1 equal sign because we're setting the data that's stored inside this variable we're setting the data inside this variable equal to a string that says rock, right? Because number 1 was rock. And then of course followed by a semicolon. Now if it's not 1, then we know it's probably 2. So then we have another else if statement, same as before, and that would be CPU in is equal to 2, right? So now we have our curly braces once again, and we have our same format as right here. We're going to copy this almost directly. So we're going to have CPU in string equals, and then we're going to have paper. So number 2 is paper, as we saw up here in our other blocks of code. And so we know if it's not 1 and it's not 2, then the only answer left is going to be 3. So we have our else statement, and of course our else statement is the default. So we know that it has to be 3. So CPU in string equals scissors. And so that gives us the whole entire block for part 2. So just to go over it, we're creating a seed for our random function. Then we're actually getting a random value between 1 and 3. And then we take that random value that we found in CPU in, and we're going to set it equal to a string value for later on. So that'll allow us to print whatever the computer chose as a string, not only as an integer. So you can pause here and finish this up, and then we'll continue on to part 3. Okay, so now we're on to part 3, which is where we actually determine like the winner of the whatever the computer entered and whatever the user entered. So our first step is going to be to let the user know where they're at in the program. So we're going to see out here, which is character out, remember, followed by the token and our quotation marks. And we're just going to write a few spaces and then have the match. And you can put whatever you want in between here, it doesn't really matter. It's total programmer preference. And then I'm going to also put just another C out in like an inline so it jumps down again, so it's not all crammed into one little space. So now that we have that done, we have to think about all the cases that we need to code now. So all the different things in which the computer would win, in which the user would win, in which there would be a tie. So we know that there's 3 possible ties, right? Because it would be rock versus rock, paper versus paper, and scissors versus scissors. So now we need to think about, okay, what about the user and what about the computer? Well, there would be 3 possible ways in which the computer would win. So there's 3 ways CPU wins, and then there's 3 ways in which user wins. So the 3 ties we already said would be rock versus rock, and paper versus paper, and of course scissors versus scissors. And let's just say this first input right here is CPU, and this first input is CPU, and this input right here is user. So now let's go down to CPU wins. Well, the CPU would win if they chose rock. If the rock would win if the CPU chose scissors, or if the user chose scissors. So that'll be a case. We know that if the CPU chose paper, it would win if the user chose, let's see, paper covers rock. And then we know the last case where the computer chose scissors, it would win if the user chose paper. So that would be the 3 cases for that. And then the cases where the user would win, the user would have to choose, let's see. Now remember, our CPU is on this side, so this would be our loser. So if the CPU, or if the user chooses rock, then we know that rock beats scissors, so the computer would have to choose scissors, and it would have to be scissors versus rock. And then we know that for the second one it's paper, so paper covers rock, so then the computer would have to choose rock in order for the user to win here. So this will be paper. And then our final one would be paper here. So the computer chooses paper, and then we also have the last one would be scissors. So these are all the cases that we have to code in our little part 3. So now that that's out of the way, let's think about how we're going to do this. So we'll use an if statement again, and we'll have 9 separate cases, and then a default case, which will be 10 cases total. So our first case, let's just take care of the ties first. So if the CPU in, so this is going to be our integer variable, remember that original random variable that we created, is equal to 1, so that'll be rock. And so in order to make this true, then we need to make sure that the user actually entered rock as well. So this needs to be ampersand, so that's what we use to determine and, just like or, it's in the same family, but this is and, so both of these things have to be true in order to get into that block. So this CPU in equals 1, and so the user in num, remember this number that we declared in that first if statement, that would have to equal 1 as well. So now we have our curly braces, and then inside this block we're going to write right here we have our string, and we have CPU, and then we can print out CPU in string, and then we have a space here, of course, remember concatenation from the last video, and then we can have here, we can have our, let's see, this would be our user, and then we can put our user in original string value, and then of course an end line, and so that'll tell what the computer chose and what the user chose, and then we can see all the results. So we have our double quotations, rock versus rock, and then tie. Now that this is done, we can actually model all the rest of them. It's very similar to this. So we have our first if statement done, now we need our second one, so we have else if, and then this one would be if CPU equals 2 and if user in equals 2, then we both know that they both chose paper. So we can just actually copy and paste that into our next thing, followed by some curly braces, of course. And then we actually can use this too. So that'll print out again. So we have our CPU and then that string that's being converted in this block right here. And then we have our user in, of course, followed by our cout message of what it is. So 2 we know is paper versus paper, and then some dashes if you want to, and then we have the tie. And then finally you do this for scissors, so it'll be the same exact thing again. So we have this, except it'll be 3. So instead of 2 here, we have 3, so they're both equaling scissors at this point. And we have our cout message, and I'm just going to copy and paste this whole block. And we have scissors versus scissors, and that'll end in a tie. So now that we have all of our tie blocks done, we can move on to our next case. So our next thing would be our CPU wins. So continuing on with more else if blocks, if you will, because this is a giant if statement. We're going to have else if, and let's scroll up here. So our first case is rock versus scissors. So we know that our CPU in would have to equal 1, and since this is scissors, so our user in num would have to equal 3. So if this is the case, we can copy and paste this again. So it's just going to pull that same data again from right here, and then we're going to have this instead of scissors, this will be rock, and then we have rock here, and then this is still scissors up there. And instead of a tie, this would actually be CPU wins, right? So because rock crushes scissors. So don't forget your C here. So now that we have that done, that's another block. So now we just have another to go. So if CPU in equals, this would be 2 now. So if CPU equals paper and user in num equals 1, because that's going to be paper versus rock, then we're going to have our curly braces and our cout statement that tells us what the CPU chose and what the user chose, and then we're going to have our results. So this time is paper versus rock, and the CPU wins again. So you're going to keep doing this for every single instance that we listed up here until you get to the final case. Now you're going to have a bunch of else if cases, so you're going to finish this once we pause. And then your final case is going to be the else statement. So if it's none of those cases that you coded above, then we're just going to see out a message that says there was an error, and we'll go from there, and it should terminate the program. So now that that's all taken care of, you guys can pause the video here and finish all the cases for your else if statements. Okay, so now that we have all of our cases done, so with your done cases, they should look kind of like this, or almost identical to this if you're following along with me. So we have the return statement down here. Make sure that's in the correct place, and make sure that your closed bracket is right after your return statement. Remember that this closed bracket comes all the way from up here in main, so you can test and see if your closed brackets are working correctly, if you can do this and condense it all into those two little brackets right there. So now that we have the program all finished, we can go ahead and run it. Now I've already clicked run up there, but now it's asking me to enter rock, paper, scissors, so I'm going to go ahead and enter paper. And when I enter that, it prints out our match title, and it told me what the CPU entered, it told me what I entered, and then it printed out our final message that it's a tie. So we know that it's working as it should be based off of our if blocks and all that kind of stuff. So you can go ahead and run this as many times as you want. And that brings us to the end of our coding challenge. So congratulations if you made it this far. You definitely learned a lot today as far as the basics of programming. So that's awesome. If you need a little bit extra help with everything, you can go to the C2 STEM Lab website, and everything is listed step by step as far as just instructions and an answer key for the actual CPP file itself. So that being said, thanks for watching. I'll see you guys back here again next week.